Hello everybody, this is Kai from Raising the Bar, and in this video I want to implement the suggestions of exercise 2.5. This will be about a scatter plot. Along the way I'm going to discuss the definition of the scatter plot, and some of the suggestions of the exercise will be changed because if you use the values in that exercise, then the scatter plot will not be very realistic. Okay, so for the beginning, I want to just read what is written in the exercise, that we want to see a rough dependence between the weight and height of an adult. And for a sample of n adults, we write down the weights denoted W1 through Wn and heights denoted H1 through Hn. And there are two important things to note. The first thing is that these observations should be written in pairs because it does make sense to link one person's weight to another person's height. And the second thing is that logically it is the weight, it is the height that determines the weight and not the other way around. So when we write those observations in pairs, the first element of a pair will be the height and the second element of the pair will be the weight. Okay, and this is how I want to put here on the spreadsheet, that the first column should be named height and the second column should be named weight. Okay, below these observations we put the likely values for the height and weight. They will be random and they will be generated using the way that we already know. It will be a combination of normal inverse and random, two statistical functions from Excel. And I see that in the book, norm inv is written together without a dot between them. This is probably wrong, or maybe this was true in the previous version of Excel. So I am trying to type it here correctly. We start with the equality sign, then we say normal dot inverse. Okay, this dot is missing in the book, and then in parentheses rand for random, rand with empty parentheses. This provides us a random number which is uniformly distributed on the segment 0, 1. And then for the mean I am putting 170, and for the standard deviation, instead of 30 which is written in the book, I am putting 20, and this will give us a more realistic value. Okay, so here we see a height of an adult in centimeters. For the weight, we put a reference to the first one because actually I want an approximate linear relationship between weight and height, and therefore I start with the reference to the previous cell, that in some way weight should depend on height. And then minus, instead of 100 which is in the book, I want to subtract 50, because when I experimented with 100 sometimes I obtained a negative weight, which is impossible, plus, and then again that combination of normal inverse and random, which gives us a random observation from a normal variable. Normal dot inverse in parentheses random with empty parentheses. After a comma I'm putting the mean 0, which is in the book, is fine, and standard deviation 20, which is also fine. Okay, so we have here observations on one person, so I want to generate 20 observations like that. In order to do that, we select two cells and then drag by this small square in the lower right corner down. Since in the first row I have the labels, so if I want 20 observations I should end with row number 21. Okay, so here we have the desired observations, and then in order to see this on the scatter plot, we can go to insert scatter plot. But before doing that, I want to emphasize that a scatter plot is when we plot values of one random variable against values of another random variable. So on the vertical axis, we're going to have weights. On the horizontal axis, we're going to have heights. Okay? So I am selecting here our columns with data and labels. Then go to insert, and you see here this choice, chats. Okay? And I want to see the first one, scatter plot, okay, without the lines connecting them, because lines in this sense would not make, in this case would not make sense. And this is the chat, and you can see in this case that a person who is about 130 centimeters high weighs something like 52 kilos, and there are observations for where a person which is about 180 centimeters high weighs about 145 kilos. Okay, and then when we press F9, we will see different samples, and you can notice that in general there is an approximate linear relationship between weight and height, and that linear relationship can be found using regressions, and we're going to study this later. Another thing is that the samples, the changes from sample to sample are pretty big. Okay, so in regression analysis, this leads to a large volatility of the estimates. And probably this is all for today. That's all I wanted to say. Thank you. Bye.